This axis. About the suspension only, that's called like an axis here now. So we'll proceed like this. As we rotate the disc. And release. The wire gets twisted and a restoring torque is set up in it. Elastic restoring torque. Okay, we'll write it. Elastic restoring torque is set up in it. That will bring this to initial position. Like this, it will be oscillating. What do you mean by twist? I think this is something very important. So we are not understanding what we mean by twist. How to imagine this? Is it practically possible? Is it practically possible is what we'll start thinking. I'll give one example. Let's see that. You can take any plastic cover or your school bag or college, anything bag is, where it will have strips. Well, I'm trying to arrange it. Okay, you can see now. Huh? Let me have the video. All of you able to see this? So now what I do? I twisted, no? Are you noticing it? It will oscillate, no? So why do it oscillate? I think I'll put more weight. I'll put more weight here. You can see this one. Okay, what is that string? The string black color one. These are the strips. It's a polythene cover. Nothing is there. Where we call this handle, no? This is the thing, that one. So this is the, now I put more weight. I displaced it. Is it oscillating? Yes, it will oscillate. No? This is the torsional oscillations. Don't say angular SHM. It's angular SHM only, but you have to call torsional oscillation. The wire will get twisted. So if you take it, no, if you take it little bit long one, you can see clearly. It'll be oscillating. So you can take some towel or say, okay, I have a bag. I'll put some other things. Okay, you can see this particular bag is there. So many objects around us, you just tie with a thread or something, you rotate and displace it. So it will be. So what is the string? The string. The strip. The strips will become string, that one. So this is what the torsional oscillations, what we are discussing. Nothing big. Okay, fine. This one. So now from where that torque will come, from where that torque is set up, the torque is set up by the elastic restoring forces in the wire. So they will set up. So let's not bother, like I said, how do they torque? So, and it's a rigid body. There's a rigid body. This is an elastic wire you write so that it will flash for you. So now the restoring torque is set up. This one. So here we have given angular displacement theta like this. The restoring torque set up by the wire due to twisted wire will be like this here. So this torque should be is equal to, this is proportional to negative of C into theta, I'll write it. So what is this? C is what? Couple per unit twist. Will be different for different wires. What is this? This should be equal to I into alpha. So what is the angular acceleration? This you can write at d square theta by dt square. Now what is I? I is the moment of inertia. Mi of rigid body about the axis. So this will become d square theta for small angular displacement we are discussing. So this will be comparing with the standard equation of SHM, omega square equal to Ci, and what is the time period is given by 2 pi I by C. What is couple per unit twist of a wire? It is not of a rigid body. And for different bodies, what happens? The value of C will be for different wires. The value of C will be different, and that will be given for us. We need not to bother that one. So it will be oscillating. So how the motion of the disc will be? The disc what happen will swing like this. Just now I shown the bag or polythene cover. No, these are called as torsional oscillation. Again, you may call it angular SHM. It's a part of angular SHM only. From where the restoring torque will come in the wire. Who will produce the restoring torque? Produce in the wire. The elastic forces only will set up a torque, and that will make the body to return back to its original position. So what is the advantage of this? So can we find out the couple per unit twist of a body? So you may get things are like we are not understanding anything. Suppose if you take a wire, just I wanted to give information. There's a wire. So as you rotate, if you look at the wire, no, so the different parts of the wire will have different theta. Wire gets twisted. So if you see this part will be a twist. The different parts what happen will have different twist. The one which is in contact with the body, what will happen? Here it will have more angular displacement. Am I right? So as you swing it, the wire which is in contact with the rigid body, what happen? It will have more angular displacement. This idea, no. Next layer, it will next at the other point. The twist acquired by the layers will be different here. So these layers resulting what's happen will okay, I'll do one thing. Some are asking, sir, what is the dotted line? So initially the dotted line will be here. So when you twist it, what happens? The different layers will have different angular displacement. Am I right? Getting the idea? So this is the, I'll write A, B. This will become B dash. Or after getting twisted, so this is the twisted wire. This is a normal wire. The B itself will come here. So let me show it. It'll be better. Huh? Okay, fine now. The different angles. So here what when a restoring torque will be set up by that one. Elastic restoring torque will be set up. What is I? What is I? I will be m square by 2. Substitute that. Can we calculate the restoring couple of these things? So I'll give some small numericals so that will be easy for you. So I have a there's a wire. I'll take a little bit thin. You may confuse this to be any other thing. There's a wire and we have a cylinder. Okay, the mass of cylinder be m1. This is length L. And it's having a couple per unit twist. I will make it to swing. So then the time period of oscillations is given by 2 pi or the moment of inertia of this cylinder. M1 L square by 2L by K, 2L by C, couple per unit twist. And there's axis, no? About passing through the center, there'll be axis. Now what I do is I will place some object on this cylinder or thin rod. Okay, this again, it's a thin rod. This M1, this as usual L. I'm going to place a block of mass M2. With the new time period, this will be 2 pi. The answer will be M1 L square by 2L plus M2 L by 2 whole square by K by C. So even if I don't know couple per unit twist of this wire, I can find out the time period or other things. So I'll divide these two, or T2 by T1. 2 pi root of C will get cancelled. So what will be ending up with M2 L square by 4 by this will become 1 plus M2 by 3M1. T2 by T1, sorry. Okay, fine. Even if you don't have information of couple per unit twist, you can find out the time period of oscillation by using this setup. These are the types of numericals you can expect here. What is C? C is a couple per unit twist. If they ask you to find out, now you say that one. I want to find out this C. Okay, after I can measure T2, T1. We know M2 and M1. Or if you
Sir,
know T, yeah.
sir, 3M2 by M1, sir.
3M2 will come. Yeah, okay. So in labs, no, this is the method what we'll use. So if I place some block here, no, it's then the moment of inertia of system will change. M1 L square by 2L plus M2 L by 2 whole square. No? So this distance is how much? L by 2. If you place another block, the time period will change. Like that, even if I don't know couple per unit twist, no, I can manage this experiment by using these combinations. You do have in exams questions of this kind. Okay, how to find out couple per unit twist here. So what we can do, even we can do one thing. I'll take the difference of these two. If I take difference of these two, so we can find out the couple per unit twist. You do have wide varieties of problems of this kind. Students, what happen, they get confused. So instead of this, what happen, you take the difference of these two, T1 square minus T2 square equal to 4 pi square by C. Or I'll write one more, T2 square minus T1 square will be 4 pi square C by how much it will become. Okay, fine. Because M1 L square by 12, M1 L square by 12 will get eliminated. So M2 L square by 4, I'll get it. So now I know this time period, I kept a mass, I'll get the couple per unit twist. So in exams, how the questions will be, initially a rigid body is a thin rod solvent is contained by wire, it may slightly twist and release. The time period of oscillation is given by T1. Then a particle of mass m2 is kept at one end of the rod. Then again it is rotated so that wire will get twisted. Torsional oscillations are noted. The time period is given by T2. Then what is the couple per unit twist of the wire? This particular formula. We don't know mass, we don't know length, not needed. You directly end up from here. Okay, pi square. So this will become m2 L square pi square by. Okay, these are the types of numericals what you can expect in torsional oscillations. All of you got the idea. Torsional oscillations is different from the angular SHM. In angular SHM, what the rigid body will go like this here. Here, only the wire will get twisted. Slightly it will rotate here. So how the position of this will be. So I'll give last set of diagram I'll give so that will be easy for you. What do you mean by torsional oscillations? With the help of rod, I'll show it. So it is like this. No? There's a thing. Okay, now the rod is like this. It can come to this position. Okay, here's what we have given angular displacement theta. The restoring torque in wire, it is set up like this. Okay, agree this. So this is a route. Angular SHM is different from torsional oscillation. So when the torsional will come, when wire will come, the torsional oscillations will come into picture. So it will be vibrating in this particular plane. It's a very, you can see, you look at the mains exams, no? You start from the background, torsional oscillation, damped oscillation, forced oscillation, simple pendulum, compound pendulum, kinematics of SHM. Go to the exam, you'll be very comfortable. Huh? Any doubt you have, you can ask me. So what is C? C is a couple per unit twist. For different wires, it will be different. Okay, any doubt you please just clarify. Damped oscillation, forced oscillation. If you have anything, you can just clarify it, because it's just only theoretical information, no? Not like numericals where you can think. So you do one thing, just type in Google. You get so many images, so many things, so many diagrams, or in YouTube you check the videos. No, you can really enjoy. Don't watch teaching one. Say I'm telling this one. Don't watch again somebody's class. Again, if you take any teacher, you'll write the same equations. So what is watching again and again the equations? Instead of pen, try to see the physical example. Like any diagram, also like any lab, any experiment that is performed to oscillation. See once so that you'll come to know, oh, this is what I'm studying. Then it will be very easy for you to remember the formulas. Getting the idea? This is so please students, like you have now very nice, you can, what I say that opportunity for you to learn systematically. I'm saying systematically that one. Just type in Google. So many practical videos are there. I don't know students open. I'll ask them to take help of YouTube. Again, there was some other teacher's video. The same teacher will be writing these equations. Tell me what is the fun in seeing the same content again and again. Instead, what when you watch something which are practical diagrams, torsional oscillations, practical demonstration in lab of torsional oscillation. Type it. See, when you can search movie, I'll ask you to search movie. Everyone will search movie because you are interested. When I ask you to search on torsional oscillation, students are telling me, sir, how to search. You're not interested. That's why you're asking me. See, It's a very pity that when I ask students like, okay, in Google you can search it. They're asking me, sir, like how to search. You know how to search movie. You know how to search game. Then why can't you search this? This shows the level of interest. No, when you're interested, what happened? All things are possible. When you're not interested, then everything will become question mark. Hmm? So explore the subject using the videos, using the practical demonstrations, using the images. Okay, don't read theory again. So go to website again, they'll give some information. Okay, you read that theory. The theory is same thing. No? What is use of this? You open textbook available. The one which is not there in textbook, that you search in internet. That'll be much better. Hmm? Plenty of videos are there, practical demonstrations of damped oscillation, forced oscillation, torsional. See once, it'll be easy for you. Hmm? Okay, all of you. So take help of the internet available for you. Very nice way to learn things systematically. So we'll stop the class here. Okay, thank you, all of you. So read theory once and try to solve simple objective questions available in mains. That one in advance, it's not there. Only in mains, previous exam papers, the questions available. If you want, I'll post it them. You can try them. Fine.
Thank you.